hasn't reached us. So no matter how hard we look into the sky, we simply won't be able to see it. We can only see the stars whose light has had time to reach us in the 13.7 billion years since the Big Bang. This region is known as the observable universe, and there are not enough stars here to light up the night sky. So we only ever see the stars and galaxies whose light has had a chance to reach us, and that's why it gets dark at night.
The simplest of facts that we take for granted, that the sky at night is dark, is in fact incredibly profound. It took 200 years of theorizing, of thinking. It took the development of general relativity before we could understand why the sky at night is dark.
By reasoning and observing and imagining, we've found ever better ways to project outside of the confines of our small rock, tumbling through space. We've become ever more skilled at creating pictures of everything. This is a computer simulation of the universe in its infancy. Using it, we can see how the force of gravity has shaped the universe over billions of years. The brightest white and yellow regions in this image show where galaxies and clusters of galaxies form. You can see how, as the universe evolves, a strange and hidden structure begins to emerge. This is the cosmic web. It's our best picture yet of what everything might look like at the largest scales. It shows massive clusters of galaxies linked together in vast filaments, each one containing trillions of stars. Its scale is sometimes difficult to appreciate, but it would take light almost 10 billion years to cross the distance in this image.
Nossa, como é lindo, gente.
But this incredible picture of everything is destined to change. We're starting to understand that in the distant future, the universe will become a terrifyingly bleak and desolate place. In 1998, a team of astronomers published a paper in which they looked at supernova explosions in distant galaxies. They were hoping to measure very accurately how fast the universe was expanding. Now, they expected to find that the rate of expansion was slowing down, just because of the pull of gravity of all the matter in the universe. But they were in for a big surprise. The universe was getting bigger faster. The rate of expansion was accelerating. There seemed to be some mysterious force pushing everything apart. We still don't understand its origin, but it's been dubbed dark energy. There's one fascinating yet disturbing consequence of this. If the expansion of the universe continues to accelerate, then our visible universe will begin to empty. Let me explain. Imagine I'm in a distant galaxy that you can see from Earth. Now, as the space between us stretches, there'll come a time in the future when it's expanding so rapidly that light can't outrun it. and the galaxy will disappear from view.
Nossa.
What this means is that far into the future, some 100 billion years from now, if intelligent life forms still exist in our galaxy, they'll look out into space and see only the stars in our own Milky Way. All the other galaxies will have disappeared, and they'll be alone in a vast, dark, empty expanse.
Nada. Nossa, muito interativo
I have
isso.
here a box. What would happen if I were to remove everything I possibly could from inside it? What then exists inside the space in the box? Is it really nothing?
Muito interessante.